Hello everyone, you are welcome to topic 5 in this course of artificial intelligence, concepts, challenges and opportunities. In topic 5, we are going to introduce a few concepts of knowledge, reasoning, inference and uncertainties. We might concentrate more about uncertainties and probabilistic reasoning in this topic. Okay, so the outline of this lecture, that we start by giving some definitions about inference and reasoning. Then we go to concepts of probability theory and examples. Then Bayesian theorem. Then intelligent robot football game. We take it as one example about Bayesian, or based on probabilistic modeling or probabilistic reasoning. Then we talk about Bayesian inference. So of course these topics are quite large. If we want to go about every topic in details, the probability theory itself, it can be like one semester, one course, complete course. But we try in this topic, within these 2 hours, we try as much as we can to emphasize the main things in this topic, without going in every details. So reasoning and inference. So we know that in order to build intelligent agent, we need to, of course, as we mentioned in the previous lecture, we said that the intelligent agent will collect data from the environment, so they can have input from the environment. But this is not enough, of course. Once we have this input, we need to build some conclusion based on this data. Okay, so we need to build some like reasoning and inference capabilities in order to take a proper action. So we can say that reasoning is related to how to form inferences about the problem. Of course, we as a human, that we have this the most advanced capacity about inferences and about reasoning. So we can, for example, base it on what we see, or even we don't see sometimes, that we can build some sense of things, applying logic, establishing and verifying facts. We can change or justifying or modifying our practices, institutions, and also beliefs based on new or existing information. So we can extend our beliefs, or we change them based on what we see, or even which are unseen. So sometimes we don't have to see everything, so we believe in something, like for example quarks or electrons. We don't see them, but we believe that they are there, and we can also model them. However, for AI agent or artificial intelligent agent, it is not possible, of course, to build such complete reasoning. For example, it is impossible to build AI system with consciousness. So they don't have consciousness like a human. Consciousness, it means that we are aware of ourselves, that we are here. So this is, of course, is not impossible to build in artificial way. So what kind of reasoning and inferences that they are there? So I believe that most of you, you may study this in high school. So we have the common three, that deductive or inductive or abductive. Of course, there are some others like backward inductive. There are also some other kinds of reasoning methods or inference methods, but let us talk mainly about these three. So deductive means that we start from general and we go to some specific. So this way of reasoning is applied by human, and also we can somehow implement them in machines as well. So it means that you start from general. Let us take some simple examples. For example, if we say that we have logic X, or we have set X that contains all numbers, for example, ending with 2. Okay, so we have all numbers ending with 2 is in set X, and we have Y. We can build a logic that all sorry for not nice writing, because I don't have full control, but all numbers, for example, ending with 2 are divisible by 2. Okay, so this is like a theory, or like a general. So all numbers ending by 2 are divisible by 2, and X is all numbers ending with or by 2. So if we take, now this is a general rule. So if we define that we have Z is equal to, for example, 42 is a number, is 42, as you can see. So since X logic leads to Y and Z belongs to X, then Z will be belongs to Y as well. So from general we go to the specific. So we build some general rule, and based on the general rule we can go we can check the specific rules and we apply them. For example, it is generally harmful if you drive in very high temperature environment, like more than 48 degree, for example. It can be harmful for people aged more than 70 years old. Okay, so this is a general rule. If people are more than 70 years old, it will be dangerous if they drive in a temperature of more than 48 degree, for example. Okay, now we can say that Matti is age is 72. Then it is dangerous for Matti to drive in this temperature, and the temperature is above 48, then it is dangerous to drive. So we can build the general rule, and then we can apply for the specific. So we can of course implement this in the machines. However, sometimes we end up with what is known as overgeneralization. So this can lead to some wrong conclusion, which sometimes they are done by the machine, but for the human, by sense, they cannot do that. For example, if you put a general statement that all seagulls are white, then this is the general statement. Then there is one mouse. This mouse is white. The machine, if it is not constructed very well, it might end up that mouse is a seagull. So this is, of course, wrong conclusion in this case, or it is called overgeneralization. So one should be when build this deductive reasoning in the AI, one need to be specific and how to select the general statement and the conclusions as well. Then we have the inductive. The inductive actually working in the reverse direction of the deductive. The deductive, we start from the general and we go to the specific. The inductive, we start from the specific and go to the general. Actually, I can say that most of the learning algorithms, like in machine learning, they are based on this inductive. That we have data, this data representing certain cases, and from this certain cases, we try to have some general impression or some general conclusion about the problem. Okay, so this is called inductive reasoning, going from the specific to the general. We observe, we have some observations, and based from these observations we try to build a theory. Okay, for example, if during all your life you see only white seagulls, okay, then you can end up with a theorem or theory to say that all seagulls are white. So this is a theorem based on observations. Okay, this theorem will be valid as far as no one could break it. So if someone find seagull which is not white, then of course the whole theorem will be broken. So you cannot say that all. Maybe you can say change for the, this is the modification from all, we can say most in this case. So if, again, the inductive is based on observation. You look to the observation. From the observations, you build a theorem or theory. It came also to my mind. This is in Maxwell's equations that they are 4 equations. 3 of them, at least, they were based on what? They were based on experiments. So they were in labs. They, for example, move the wire in a magnetic field. Then they observe that there is electricity going on, and then they try to measure the electricity compared with the field itself, and blah blah blah. So maybe if you take physics 1, maybe you still remember. So they build a theorem. So this theorem actually, which control, or which represent the electrical current with, for example, magnetic force and so on. So when they build these equations, these equations are theorems, but those theorems were based on some specific measurements or observations. So it is inductive. So it is inductive reasoning. Okay, but the 4th equation, which actually was bought by Maxwell, it was based on deductive. So we have from 3 equations he built the reasoning to have the 4th one. Okay, and the abductive reasoning actually is based on if we have some uncertainties, so we don't know what is the reason for some result. So we see some result and we try to go back to see what is the cause of this effect. So it is based on cause and effect, but it is not deterministic. It can be like it is associated with uncertainties. Here we have some kind of innovation, so that people can innovate some new causes that they didn't see before, so they can build it or they can justify that this effect had been by that cause, even it is not clear that what was the cause. For example, if you prepared your cup of coffee and you put it on your table, and then you went somewhere, and then you came back, you find your cup is not there, or the coffee is empty, the cup is empty. So now you start to think, who did that? So maybe your office mate, he drank your coffee, or maybe the person who cleaned the office, he took away this and cleaned the cup. So you start to have about some causes. What is the reason for this? Who drank the coffee? So this kind of reasoning is called abductive reasoning. So the abductive reasoning, that based on the effect that you see, you try to build the cause. What was the cause? Okay, so actually for the abductive reasoning, maybe it is one of the most difficult parts in AI to be implemented in AI, in artificial intelligence, because it is specific to general. It is quite similar to the inductive, but now you have different kind of reasons. So when you build intelligent agent, you can put all possible reasons, of course, but in real problems, it is hard to say that all possible reasons. Sometimes they can be even cannot be counted how many reasons that could happen. Of course, you can put as much as you can, but sometimes is not always working. For example, if we take the reason of the cup of the coffee. Okay, now you go that your friend or your coffee office mate drank it. The cleaner who took it out and cleaned the cup. So you can start think about many reasons. You can put them in the intelligent agent if you ask it, the intelligent agent. But there can be some strange reason. Maybe you yourself, you drank the coffee, you cleaned the cup, and you forget this completely because you was doing some like very your brain was very busy with some that in working in some scientific paper, you derive some equations, so you was completely like concentrating on this problem. So you drank the coffee, you clean the book, clean the mug, and you forget completely about that what you did. So this is also possible. So you cannot count how many reasons can happen even in this simple example. So this abductive reasoning is very, very important as well. Logical reasoning, actually I will not talk that much about logical reasoning for one reason, that it works mainly when we have deterministic environment. When we have deterministic environment or almost deterministic environment, it means that you can put all reasoning or you can draw the whole cause and effect cases, and then you can implement them in your AI or in your intelligent agent. So here we have three critical requirements for the logical reasoning, as we mentioned before. Sensing the environment, so you have information about the environment. Then specific objects and goals, of course you should have goals to achieve. The ability of inference and deduction, so you can put some logic. Of course the logic can be in the context of if then, if this happened then that, if then. So if you can put any problem in finite set of if then, of course you can build this logical reasoning. Then to have logic, we need at least two requirements: representing the event of the environment within certain syntax. So you have certain syntax to represent the events from your environment, and then giving semantic for the syntax. So it means semantic means that you give meaning for the syntax. So you put syntax and you put meaning for that syntax when it is read by the intelligent agent, your IA, and then you build the logic. You can build the logic that it can be easily defined over this semantic. So based on the semantic, the meaning of the syntax. So you have sensors, you have camera, so you read this, you convert everything to certain syntaxes, and then you put, of course you have already semantic for the syntax, and based on that you can start define your logic, how your IA will react based on each situation. So it can be put in, for example, in the form of if then, and so on. I do remember that when I was in high school, I had at that time very primitive computer. It was that computer which connected to the TV screen. If maybe you don't you didn't see this such computer before. It was very basic computer. It was based on a processor called Z80, something like that, and the language of that computer was basic language. And we remember that we were writing some AI codes with, but it was very basic. For example, it is based on context. If you ask it what is your name, then we put if the statement, the input is what is your name, then you answer it. So my name is blah blah blah, and then we wanted to make it like quite general. Then instead of what is your name, what is name, and what name is, we put all possible ways how to say what is your name. Of course nowadays you can have these keywords, you can read the keywords with artificial intelligence, and then you can see what the person asking about, what is the question, or you can build, or you can guess what is the question. But at that time we put everything like if then. It takes hours to write the code. So this is the syntax and semantic for that syntax, and then the response or the logic based on that. So this is called logical reasoning. However, that as I said in the beginning, for the logical reasoning to work, it needs to have well-defined environment, which is not actually the case when we talk about like real life applications, not at least not always the situation. And you might have worked before with some artificial bot that, for example, in the maybe Amazon or PayPal, for example. So you might have a problem that you want to represent them. So usually they start with this artificial intelligence that you can communicate with it. So and when you are writing, sometimes you of course they can handle many cases, but also there are considerable number of cases that they fail to understand what you mean or what you want to say, and in that case they should be a human in between to communicate with. Me myself, I have some problems happened with that, like intelligent agent, like representative of the company. Okay, so now we came to the probabilistic reasoning. Actually, the probabilistic reasoning is much more like flexible and gives us a lot of features that are available today. By the way, if you go to the logical reasoning, it was there since 60s and 70s. People, they were thinking about how to make intelligent agent, or how to make like artificial machine to think in a proper way like a human. But maybe 30-40 years nothing happened. Actually, they achieved very slow achievement on that. They were working in very limited environment, very deterministic, well defined. They can work, but when you go to the real life, how many things uncertain around us, so this is not the case. So it was failing when they take with uncertainty. But when we talk about probabilistic reasoning, they are very important, because in probabilistic reasoning, even if you don't have full information, or you have missing information, or maybe some situation that was not already like implemented in your like an intelligent agent database, then still the system can take some reaction and to have some response, the proper response or the best response based on the available information. So this now we can talk about like Bayesian reasoning and Bayesian inference. But in order to talk about these things, what we need actually to know, we need to revise some probability theory, or some concepts of probability. I know that most of you maybe you study probability before, but it is still good to revise this probability theory in very fast way. So in order that to remind you about the concepts of probability, and for those who forget or didn't study this probability theory before, then they can know something. So now let us stop here. So what is next here? Yeah. So we just talk more about probabilistic reasoning. So yeah. So we let us complete this in the second clip, so we can talk or second video we can talk more about probabilistic reasoning and probability theory. Thank you very much.